All right, everybody, here we go. This is going to be a whirlwind of technology day right here. So I'm going to start. I have my iPad loaded up onto the computer because we need to both write and we also need to see a lot of TI calculator. We need to see a lot of, or we're going to talk about Desmos. We're going to talk about the CPM stuff. We're getting into simulations here is the big thing that's going to happen in this chapter. We're mainly going to stick right here. Desmos, this is the rare thing that Desmos is just not my favorite on. I just don't think that it's super useful. We might find a use case or two for it, but until we get some kind of random number generator stuff that's a little bit more friendly, like random integers, either the CPM stuff or Desmos is going to be kind of your two go-tos there. So let's take a look at this lesson. Let's see what this looks like here. So jumping forward here, our first question says this: a girl or all boys? Mr. and Mrs. Sitman want to have children, would love to have a girl, but they don't want to have more than 4 children. They want to figure out what are the chances of having a girl if they have children until they have a girl or until they have 4 children, whichever comes first. Since a coin's a 50-50 chance of landing on heads, a coin can be used to model this real-life probability of a girl being born. So, first off, talk with the team about how you can use flipping coins to determine the probability of having a daughter. So, the obvious way there is you could just say something like, heads is a boy and tails is a girl, or just flip them and say that tails is a boy and heads is a girl. Nothing real crazy there. So we're going to jump and we're going to load up this CPM tool right here. So student, so 11.1 student tool here. So I'm just going to get that loaded up here. When you click on that link, it should open up something like this. So you've got your kind of heads or tails here. And then in the problem, it says this: once your class has done this, plan the simulation, found a method for tallying results, run a simulation to check it out here, and do it for 25 times. So basically what this is going to be is we've got these 4 coins here, and we're going to stick with the heads as a boy, tails is a girl. So what I'm going to do is I'm going to flip this coin. Heads, so that means that their first child would have been a boy. Tails, their second child would have been a girl. So in that first simulation, in simulation 1 here, they had a girl. In simulation 2, we'll have to go back and we'll check this out. First one, they got a tails right away. So they also got a girl. Simulation 3, and so on and so forth. And we do that, and we'd keep doing this until we find out, is this going to be the one? Yep, this would be a boy. So all 4 of them flipped heads, and so we had gotten 4 consecutive heads, so this would have been a boy. Man, I got lucky there. Most of the time, it's not going to work like that. But you would do something like this, and then, again, you would have a girl, and so on and so forth, going back and forth, and then you do that for 25 times. You don't necessarily have to do this. More of it's just kind of get the idea here for this. So once the team has modeled the 25 trials, then you go and you would combine your results with those in the rest of your class. According to your class's simulation, what's the couple's probability of having a girl in this situation? Well, if you do this much more, you'll find out that it's not 3/4. You'll find out that, and just kind of realistically, like, think about it, you're really asking the question, what's the chances of flipping heads 1, 2, 3, 4 times in a row? That's kind of really what you're asking there. And so, yeah, that is basically what you would do and what you'd find out. There is what's called the theoretical way. Theoretical, hopefully I spell this right. Just write it sloppy because then you can't tell. That we could calculate this, but sometimes specifically, and this is what we're going to be looking at in this section, sometimes the theoretical is really, really complex. And it's like, well, I don't really know. And so sometimes they will actually do these things here that we'll call samples, or I forget what the word is here. Let's jump back. A simulation is what I'm trying to come up with. A simulation, and we'll do a bunch of simulations just like we would have done here with our 25 samples, and then of course you do the 25 samples across your different class groups, and you'd have a large amount of data there that would in theory get you closer and closer to what that actual theoretical number is there. So that's kind of the big idea in this chapter. This is just question 1, so let's see what question 2 looks like here. So question 2 says, in the simulation for problem 1, do you think that more trials would lead to a better estimate of the probability. Absolutely, that would. More and more, because if you only have four, just like we saw the first time, I had 3 out of 4. That was 75% chance. Well, if we end up doing more of those, I promise you that the flipping heads 4 times in a row is not going to come up at 75% chance. It's probably going to be closer to like 90. So we're going to try to do this a little bit of a faster way though. So we're going to show you how to do this on the TI calculator, and then we'll also take a look at how to do this on the student e-tool here. So let's jump over, going back here, jumping back to our student e-tools. This was 11.1. We'll close that tool, and now we're going to go to this one. So now this one, in this case, a 0 is a boy and a 1 is a girl. So now instead of having to click 4 times, I can just go once and go, okay, I had a girl here, so they would have stopped and not counted this, and so now just with one click, I can find out how many times I have girls. So I have girls once, then a boy there. Wow, I am getting super lucky here. And then boy again, girl, 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 and so on and so forth. You can see that even though I had those two kind of outliers, or so far I've had 3, you can see that the girl probability is just going to be much higher because it's just hard to end up rolling 4 heads in a row. The fact that I did it back to back too was even crazier. So that's kind of how you would use that like CPM tool, and then you just have to kind of write it down. If you were going to use the TI calculator, so I'm just going into this standalone calculator. You guys have that link in there. And I'm going to use the TI one, not the Desmos one. So I'm going to use this first one because in the thing, it kind of showed this. Let me jump back to this here. It shows this random integer here. So random integer, and it'll ask us to set a few parameters on that. So let's see what that looks like. So under math, we're going to go over to probability. And then down here, we've got rand integer, which stands for random integer. So we'll just click on that. And it's going to ask us what are the upper and lower numbers that you're randomizing. Well, here we're going by from 0 to 1 because we're trying to figure out boy or girl there. And then we'd say that we're looking for 4 trials, and we just paste it out. And you could do kind of the same thing here. So that'd be a girl, 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 and so on and so forth. But the thing that's kind of nice about this is that you've got your data here. So I can scroll back and kind of find out and just have a better way to kind of count it out and go forward from there. And so there is our first boy there. But now I can just go through and see kind of all of these trials here. I had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and it took me down to the 13th trial before we got our first family of all boys there. So that's kind of what they are talking about here to do it on the TI. So let's take a look at our next question here. Our next question is 11-3. It says this: we simulated this stuff in problem 11.1 and 11.2. The theoretical probability is not actually too complicated to work out. So work that out with your team and find that out. Well, you're basically talking about what's the chance of flipping heads 4 times. So that'd be, you'd have a 1/2 chance times the next throw, times the next throw, times the next throw. So that is your chance to throw all heads. So throwing all heads there, you would end up with, let's see here, this would be 0. I'm just writing this number down from my notes here. 0.625. This is the chance to throw all heads. So say about a 6.25% to get all boys. So then if you're looking for what are the rest of them, well then the rest of them would be girls. So you'd have a 93.75% chance to get a girl, which sort of lines up a little bit more with the TI calculator approach, because we had 1 out of 13. So that's a little bit closer to that kind of 93 percent land. And then of course that original thing where I had 3 out of 4, well that was clearly like super weighted wrong, because that is a 75% clip there. So that is that. Our last question here is just talking about this, the law of large numbers. So according to the mathematical principle known as the law of large numbers, the more times you run your simulation, the closer your result will be to the theoretical value. So this is a bit of what I talked about at the beginning. And so basically, what it's saying is that if is that the more simulations you run, the more that you're going to kind of get rid of outliers because you're just going to have more and more data to work with, and the more and more data you have, the closer you're going to get to that actual expected or theoretical value there. So which if we would have been following all those instructions and done it on the graphing calculator, maybe found 50 samples instead of 25 samples, you would have gotten closer and closer. And so that 1 over 13, I actually don't know what that is as a decimal, but let's just see here what that is. So 1 over 13. Let's see here. So we're getting kind of close there because the inverse of that for girls, we were at that 92.3 per percent, which is pretty dang close to our 90 to our excuse me. So we came up with in my short little one like 13 samples there, we got to 92.75 percent. Excuse me, we got to I am looking at the wrong number here. We got to 92.30 or 31% when the theoretical was 93.75%. So the more samples we got, the closer we got instead of that 3 out of 4 where we originally had 75%. So that's just really what it's trying to say there, is that. So I think that might be everything that I've got. That is everything that I've got here. So just check out the review and preview and let me know if you have any questions.